all on PW Gatewala channel. Today in this specific session, we are going to start the operating system series, and in that particular series, we are going to discuss the very first chapter, which is CPU scheduling. So in this particular CPU scheduling, what we are going to learn, what is process, how the processes are running in the system, and many such kind of things we are going to learn. So before we start, just let me know if my audio and video reaching to you guys clearly so that we can continue, and let's get it started. So first of all, what is operating system? We will discuss that particular thing. Operating system is a software. Yes, my dear friend, it is a software which runs on your computer system. But what is used, sir? Why we use that software? That is the software which is like an intermediate between you and your computer system hardware. You cannot use computer system hardware if you don't have operating system. Oh, is it so? Yes. If I'll give you the best configuration computer system, the fastest possible CPU, the fastest possible hard disk, fastest possible configuration, the best possible configuration of computer system, but if I don't install operating system on that CPU, then you cannot install any app on that. You cannot access the hard disk. You cannot store any file. You cannot create any file. You cannot open your reels. Sir, that is most important part of the life. Yes. So whatever you want to do on your computer system, you want to use your CPU. How? Directly you cannot use as a user. If you want to install the app and you want to run that app on your processor, you cannot do that until you have operating system. So operating system is that much important. Yes, my dear friend, it is a software which is running on your computer system hardware, and it provides an interface, between user and hardware. There are so many facilities operating system provides to you as a user. Of course, like it provides lot of utilities called as APIs for you guys, so that you can do the development, software development. That is a very different part of operating system, but basically OS is that software which runs on computer system so that you as a user can use the hardware. That is one of the point you need to remember. Now let's go to the topic, multi-programming OS. There are a lot of types of operating systems. Depends on what facility we want from the operating system, what kind of computer system we are building. We want a computer system to be used by multiple users simultaneously. Yes, at the same time, multiple users using the same CPU, same hard disk. Is it possible? Yes, multi-user operating system makes it possible. If you want to have an operating system used or some kind of a software used in the microcontrollers, like embedded systems. What is that, sir? See, you have seen nowadays, right, that cars are having lot of good softwares and chips inside, intelligent systems in the car. Have you ever heard in the advertisements that the ACs have become intelligent? That they can control the room temperature. If you have set 16-degree temperature, they'll keep 16-degree temperature by cooling, or by doing something, increasing the fan speed or decreasing the fan speed, like that they will maintain. But how? There should be some kind of a processor inside. But how that processor runs? Without operating system, it will not run any kind of app or any kind of program. Yes. So that operating system is also there. But that is a different kind of utility, na sir? Yes. And that operating system called as embedded system. So we have different types of operating system. One type of operating system is this. Now I am assuming, you can raise your hand if you are not understanding that. I am assuming that you know what is CPU, processor, which does all the work of execution of programs, etc. You know about it? Do you know what is RAM? RAM is what? RAM is the main memory where all running programs should be there. Why, sir? Just because whenever CPU runs the program, from where CPU will take the instructions and programs. In the RAM, those programs are there. CPU will take one by one instructions of the program and runs it. So you must know what is RAM. If you don't know, just let me know. Yes or no? Tell me, Re Baba, if you are understanding. Yep. Okay. Now, see, what is multi-programming operating system? Multi-programming operating system allows more than one process, multiple processes for sure, to be in main memory. So what it says, in the main memory, okay, so this, let's assume this is the main memory. Okay, so in the main memory, you must have one mandatory software, which is operating system, should be always running. Apart from that, apart from the operating system, multiple other processes can be there or should be there. Process number one, process number two, process number three, and so on. Oh, so many, yes, multi programs. In main memory, multiple programs are there. Now you tell me, how many CPUs are there in your computer system? How many number of processors you have in your computer system? I am not saying how many cores. I am saying how many processor, how many CPUs are there in your computer system. You tell me. Tell me. Type. How many processors are there in your computer system? One. Only one processor is there. One CPU is there in your computer system. Yes. If only one, I do have. This is also a computer. I do have two more computers in front of me, both, and this one also. In fact, my phone, this phone is also having single processor only, Re Baba. So if one processor is there, one processor will always execute one process at a time. Only one. So you kept so many processes in main memory, but you are executing only one at a time. I am saying only one at a time. For some time, I'll execute one process. After some time, I'll execute another process. After some time, I'll execute another process. Like this, my processor, my CPU will execute processes one by one by one. For how much time a processor will run a process? That is what the CPU scheduling chapter, we will learn that in detail. But what am I saying here? I am saying, Babu, at a time your CPU can execute only one process. See, CPU is not you. You can open multiple tabs. Yeah, right now, you are listening to me, using your phone also, reels, etc., chat, etc., doing something, listening to somebody else also, doing some other task also, maybe having some food also or something. But you can concentrate only on one place at a time. Don't tell me lie, okay? ना झूठ मत बोलना. I know. At a time, you can concentrate on only one thing, na. You are also CPU. You can open multiple tabs at a time. You can use your phone at the same time. You can open my lecture also, can do certain other tasks also, but concentration at a time will be on one place only. Yes or no? Yes. That is what CPU also does. At a time, single CPU can execute or can run only one process at a time. CPU or processor is same to same thing, beta. Processor or CPU, central processing unit, full form, or a processor is same to same thing. You can call it as a microprocessor also. Okay, fine. Now, what am I saying? CPU will run only one process at a time. If CPU runs only one process at a time, then why you are keeping so many processes, sir? I'll tell you. You need to know certain things before I'll tell you. See, do you know there are three components of system: CPU, main memory RAM, and then IO devices. IO is input output devices. Okay. See, about these, I have already discussed in the COA classes. If you can understand Hindi, it is there on the channel, the branch channel in Hindi. If not, then of course here also I'll bring. No worries at all. CPU, central processing unit, does the processing task. Main memory, used for the storage purpose. Whichever current running programs are there, all those running programs are there in that process, in the main memory. IO devices, input output devices, whatever other device you can see in your computer system, apart from these two, all are IO devices. Monitor, whatever, screen or whatever, okay, keyboard, mouse, hard disk, USB drive, camera, microphone, printer, speaker, everything is IO device. Now you know what happens. What happens? See, what happens when CPU runs one process. Of course, that process will need a certain IO operation also. Of course, the process may need some disk operation. So right now, if process is using CPU and now process wants to use disk, process will leave the CPU, will go for accessing the disk. Disk means your hard disk or SSD, whatever you have. Now, if process has left the CPU and using the disk, which one will use the CPU then? Is there any other process you have? No. Then your CPU is free. That is a disadvantage. So to overcome from that disadvantage, multi-programming system has been taken into consideration. So what scientists have told, if let's say one process is running on CPU P1, this one, and let's say that process has gone for any IO device use, then other process, we have second process that can run on CPU, so that CPU will become busy, we can utilize the CPU. But sir, why so much concentration on CPU? Just because it is the fastest device of your computer system, main device, the heart of computer system. And if we can utilize it more and more and more, in lesser time we can execute more processes. Performance, sir, performance, yes. And that is why we always try to increase the utilization of CPU, and that is why this multi-programming operating system is there. So what it say? It says that if one process goes for IO operation, leaving the CPU, other process is ready to run on CPU. If second process also goes, then third process is ready. It's something like, I do have a television at my house. Just assume television is CPU. I have purchased a television worth lakh rupees. I don't have, I'm just assuming you also have a television of 1 lakh rupees at house. Very costly, very big, very great television. Now you want to utilize the television more and more and more, but you are only one person at house. When you are watching the television, fine, but when you are not watching, let's say you went to college or office or somewhere, nobody is there to watch the television, right? So television is free, no utilization, yes. What you will do? You will have more people. Let's say you have 4 roommates, total 4 friends are living in single flat, maybe in your hostel or after the hostel or during college, after college. 4 friends living in same house. One friend watching the television. Let's say that friend has gone out. Second friend can watch the television. If that also gone out, third friend can watch the television. Usage of television will be more. Of course, utilization will be more. So if you have more number of processes, friends, you can utilize CPU more, television more. I hope you understood this particular point at least. Give me a thumbs up. So why we are trying to keep more and more processes in main memory, so that more number of so that CPU's utilization can be increased. But if somebody is telling you or asking you what is multi-programming operating system, this operating system will allow more than one processes to be in main memory. Among them, only one process can run in CPU at a time. Okay, whatever your other doubts are there regarding the series, etc., we'll discuss at the end of the series. Okay, at the end of the session today. I'm able to read your questions, but I'm not answering just because this, I want to concentrate on the content first. Learning first, talking later. So allows more than one process to be in main memory, and okay, I'll write the point separately. Only one process can run in CPU at a time. This is very simple yet should be known fact. Now this multi-programming operating system is having actually two types of multi-programming operating system. What are the types? Somebody knows? One is non-preemptive multi-programming operating system and other one is preemptive multi-programming operating system. Now what these two are? See, I told what happens if multiple processes are there in main memory. Among them, one will go to the CPU to run. When one will run on CPU, is it possible to take that process out of the CPU forcefully or not? Depends, sir. If process is running on CPU, how much time it can run? Will it leave the CPU by its own, or any forceful event can make it possible that process can come out of the CPU forcefully? Possible? If yes, possible, then that operating system is preemptive operating system, in which operating system has that facility that a process, if not leaving the CPU by its own choice, still operating system will force to take that process out. But why, sir? There are some event. There are some possibility. We will learn that in the CPU scheduling algorithm chapter, that when a process can be stopped running in CPU and taken out so that other process can run in CPU. When? We will understand that later. But what is the difference? Difference, non-preemptive is something like a running process can or will leaves CPU only by its own wish. When process wishes, then only process will leave the CPU, forcefully cannot be taken out. Preemptive says a running process cannot be can be taken out forcefully from CPU. That is preemptive version of multi-programming. Okay. Somebody is asking, sir, kernel versus OS. I am asking body versus heart. What is the difference in body versus heart? Your human body and heart. Heart is the part of human body. Same to same thing. Kernel is the part of operating system, the core part. If kernel is not there, OS is not there. Heart is not there, body is just a body. It will not be a living body. Same thing. Okay, now listen. Non-preemptive system, CPU will be given to a process. Process will leave the CPU only when process wants to. From outside, operating system cannot take that process out. It is something like you have given your mobile phone to your friend to play some game. Now, the thing is, your friend whenever wants, only at that time that fellow will give you your phone, otherwise will not. Non-preemptive. Let's say if you are getting late for something, you want to do something with your phone, maybe it's phone call or a message or something, you can snatch your phone back from your friend, even though your friend doesn't want to give you the phone. Your phone he is not or she is not giving you. Still, you can take it forcefully to perform your task. Forcefully, preemptive. Okay, understood the difference? Why this particular topic we are discussing? Just because when we will go with the CPU scheduling algorithms, we will have to understand that a running process can be stopped in between or not. Until that process wants, can we leave the process in CPU or we can forcefully take it out? Depends on the type. Next thing is process. Sir, you are calling so many times process, 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 process. What is process? We have heard program, but what is the difference? See, when a particular program starts running, when it comes to the main memory, that program becomes process. But what happens with that program that it becomes process? Only the terms? No, no, no. Definition is very simple, program under execution. Okay, no problem at all. But see what happens when in the program runtime activities are added. Then a program becomes process. Now you will ask me, Arey sir, what is runtime activity? I'll tell you one thing. I'll tell you one thing. There is a aircraft. Aircraft means aeroplane. That's an aeroplane. But that aeroplane becomes flight when you attach information. What kind of information? This aeroplane will become a flight, something XYZ company number 1234. That flight will fly from Bangalore to Delhi, daily morning 6 a.m., reaching Delhi 9 a.m. That is what running activity. That particular flight will go from where to where, what time flight will take off, what time the flight will land, and the timing, date, etc., etc., everything. If we have added running time activity, what? The aeroplane becomes a flight. Same thing happens here. Whenever a program you write, a tough question I'm asking. Did you write any program in any programming language ever? Just asking a question. Maybe a few of my friends are here who are in first year itself, but still, have you ever seen any program or written any program? If you have written any program, let's say I have written a program, some I inside main I am writing, okay, integer a b c, and then a equals to 10, b equals to 5, c equals to a into b, printf percentage dc. Like this, if I am writing the program, this is the program. This program, when you try to run, you know what happens? Along with this program and its code, this is the code program. Okay. Along with this code, you know what happens? Extra runtime activities are added. Along with this program, a stack is added. Along with this program, whatever variables you have created, the space to store those variables attached. Of course, 3 variables are there for A. Some number of bytes are given. For variable B, some number of bytes are given. For variable C, some number of bytes are given. I am hoping that you guys are having little knowledge of programming language. This is a C programming language statements. Sorry. So what I'm saying, apart from the program, extra storage is added to store its variable and many other things. And that particular thing is runtime activity. So when a program starts running, in that program runtime activities are added and that program becomes process. So in operating system, we hardly call program at all or hardly talk about programs. We talk about process just because we are concerned about processes to be running in the system. When that program comes for running, At that point of time only my operating system is involved, and that is why I am too much into only process rather than program. Okay, cool enough. Now you will have to have detailed information about this. Sir, can you tell us what are those runtime activity in detail? Yes, I'll tell you. See, I'll write a statement here. Whenever a process comes to the main memory, that process, each of the process stored in main memory in 4 sections. So each process has 4 sections. Yes, I'll tell you. Look at this. This I am talking about process, not operating system program. Okay, operating system is separate. This is for other processes. Apart from OS, whatever other processes are there, all processes are stored in the 4 sections. Now, what are those 4 sections? Of course, first of all, operating system is there in initial part of main memory. Apart from that, each of the process, let's say we have process number P1, then P2, then P3. So many processes are there, right? Any process you take, single, each single process you can see like this, storing content in 4 sections. What are those 4 sections? Downside we have a code section. Then next we will be having data section. Then we will be having a heap. And here we have a stack. Between heap and stack, we have some empty space. At runtime, extra space can be taken from here, empty space. These two are fixed. Now you should ask me, sir, what these 4 sections are for? Of course, before you ask, even I will give you the answer. Look at this. I told you we have, oh, where it is? I cleared it. We have a program, right? Code of the program. Yes. Code of the program, the instructions you are storing here. The instructions you are storing here. So this is the program. Here we have the program. Apart from that, these 3 things are coming under runtime activity. Okay, what data section stores? Data section stores your global and static variables. If you have any global variable in your program or static variable in program, those variables are stored in this data section. Okay, what is about heap, sir? From C programming, you must be able to recall a function called as malloc, malloc, and calloc, malloc, whatever you call them. These 2 functions are used for dynamic memory allocation. At runtime, when you are running the program, at that time, if you need extra space, then that given from the heap. So this is given to the program. When you are running the program, if program needs extra space, program will take the space from here. So it is, heap is used for what? Dynamic memory allocation. And what about stack, sir? This stack, we talk about it a lot in COA. Too much. When you learn COA, you talk about it too much time. Yes, a stack is used to store all your local variables. If you are calling the function with some parameters, then their function parameters and return addresses. And such kind of many things are there in the stack. Fine. Now, see, you can easily understand this, that when you are having a process, this is the program, runtime activity attached. When it comes to run, when it comes inside main memory, it becomes process. Why? Just because we are adding extra runtime activity. And this is not for only one process, it is for every process. P1 process also is stored in 4 sections like this. P2 process also has its own four sections. Yes, P3 also will have its own 4 sections. Apna apna. They'll have their own. There will not be any sharing, etc. Nah, no sharing. I know sharing is caring in human world, but it is computer system world. Here, no sharing at all right now. So what happens? P2 has its own 4 sections, its own heap, stack, data section, code section, everything. Same P3 also, for P4 also, and that is how a process is stored. Now, see, the thing is, no any course is something individual that you can learn directly. Each course of computer science is somehow internally connected with other course. Of course, you have a program running in computer system. Computer system means COA concepts are getting used. You have operating system to run a program on CPU, of course. Fine. Now, there is a statement which I have told already, but I haven't explained about it. Operating system running a program, yes. See, operating system is the control program of the system. Whatever happens in your computer system is controlled and managed by OS. Yes, if you know Hindi, there is a dialogue from the lot of movies. Dialogue is मेरी इजाजत के बिना यहाँ एक पत्ता भी नहीं हिलता. Without my permission, not a single leaf of the tree can even move from its place. That's one of the dialogue from the movie. Same thing happens in computer system. Without operating system's permission, nothing happens. If P1 process will run in CPU, who will decide? OS. If P1 process or any process wants to use disk, when it will use the disk, who will decide? Operating system. That much control is there of OS. Without operating system's permission, no any process can run on the CPU. No any process can use any IO device or anything. Everything happens in computer system with this fellow's permission. Means this is the Don, the king, whatever. In the positive or negative, whatever manner you take, king or Don, whatever. No, sorry. This fellow is the controlling person. Now, so you understood now what is runtime activity, what is a process. Now we'll try to understand, if we have a process, how operating system controls the processes. To control the processes, operating system has every detail of a process with them. How? See, when a process is created, when a process of course comes to main memory created, what happens? Operating system creates a control box of that process with them. In that control box, such all informations are there. What is the ID of process? Why ID? Every student also gets an ID. Why? To uniquely identify that this person is that. Same, each process has their own ID. Then, okay, leave these things. Devices. If that process is gonna use any device, all those devices name. What is the type of process? Is it a computer system process, or it's a driver process, foreground process, background process? Multiple types are there. What is the size? How much space that process will take into the memory? From which address to which address it is stored in memory? Here. Then priority. What is the priority? It is high priority, low priority, medium priority process. Priority is very important. Based on priority only processes are running. Yes. Seriously, you don't know about priority. Hey, you can set the priority. If you know about it, you can set your processes priority. Go to taskbar or task manager. Control Alt Delete in Windows system. When you go to the task manager, here the last tab is there. In that last tab, you will go. I don't remember that name right now. All the processes are there. Right click on the process, set priority. You can set the priority. You can change the priority. Yes. Of course, you can change the priority of the process. You will enjoy that doing it. If you want a process to be completed quickly, that process should not be having any kind of interrupt, increase its priority. I used to do that when I used to have old computer system with me 2 3 years ago, and I used to go live on YouTube. What happens? What used to happen? My old computer system could not take the load just because that streaming device and lot of things were running. I used to close all the unnecessary apps. Still, my system was crying grrrr, like that. So what I used to do, I used to open the task manager and I used to set my streaming software highest priority. Crying, no crying. Happened, yes. Okay, state. In few minutes, I'm talking about states. So what a process does at a time, that defines its state. Next is list of files. What are the files the process has already opened? Those files also, operating system keeps the list of that so that OS knows this process is opening what files, using what devices, in memory where it is stored, etc. But why that is needed? You guys are in college, right? Were in college or are in college? For sure, you have been into the college somewhere. School, college, somewhere. Study to kiya hoga. Are any place you went for some education, na? Of course, that's why you are listening to me here. Otherwise, why? Why you are learning computer science? So if you are in college, then college people take a lot of information from you. What is your name, date of birth, phone number, your parents' name, their phone number also, your address, communication address, permanent address, everything. If you are in college, 12th degree, 10th degree, percentage from where you have done your 12th, 10th, which board, CBSE board or ICSE board or your state board, which medium, every detail they take and store it there in in their database. Why they do that? To control you guys so that you don't leave their college and take admission somewhere else. Otherwise, you will take admission here also and there also. You become Rencho, learn everywhere. Right? No, you don't do that. So to control you guys, college people are keeping information about you. Same thing. To control the processes, what happens? The operating system is keeping the information about the processes. And those information, these informations and few more informations. Now you must talk about this. What is this, sir? These are the registers. Register values, not register values. CPU are having registers. Why these are used? I'll explain later. Okay, so now look at this. All these informations are actually stored in a box called as PCB, process control block. So you know what happens? You can imagine this is main memory. In main memory, you have operating system at initial place here. And apart from that, let's assume we have three processes, P1, P2 and P3. So P1, P2, P3 stored in these four sections. P1 4 sections, P2 4 sections, P3 4 sections. But to control these processes, this operating system is having three PCBs over here. Process control block of P1 here, PCB of P2, CPU OS keeps inside it, and for P3 also, so that operating system can control these. Which process will use what devices, what files, process is stored from where to where. Every detail operating system keeps about the processes here in their process control block. Okay, now can these values change? Let's say at a time, currently P1 is having its PID P1, whatever devices it is using currently, those, its type, its size, main memory limit, priority, state, files. These values will change afterwards or can change afterwards after some time. If these values are checked again for P1 process, same value or different values? Tell me, same values or different values? Of course, they may change. Of course, these values can change. Maybe currently process P1 is using camera, later on not using. So devices, list of devices will change. Maybe process P1 has opened a particular file, later on not opening any file, then this may change. Yes. Sorry, I'm really sorry. I'm not well. Zukam hai. I'm suffering from flu since last 4-5 days. Sorry. So I'm saying that whatever the values of these fields we have here in PCB, that collection, that PID is this, PC value this, GPR this, list of devices this, type this, size this, like this, all those values of a PCB called as context. Context is nothing but content of process control block of a process collectively called as context of the process. At a time, whatever these values are called as a context. Okay, now what happens? When I say there are lot of processes, P1, P2, P3, so many processes are there in the main memory. Operating system is there. If I say among them, one process P1 is there in CPU, what does it mean? This P1 completely will go in CPU? No, 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 no. If I say P1 is running in CPU, that means P1 content, everything is here only. Its stack is here only, heap here only, code section here only, data section here only. Then what goes inside? Context. The context goes. What is the context, sir? Whatever register values we have, PCB of P1. Let's say this is PCB of P1. So PCB of P1 means in that PCB, we have these register value, general purpose register, program counter, and whatever CPU has, inside CPU, a lot of registers are there, small registers. These registers are used to run a process. So when process to run, P1, let's say, so P1's register values will go here. What should be initial value of program counter? What should be the initial value here in this register, here in this register, here in this register, like this, so that process can run forward. So when a process goes to the CPU to run, what goes inside CPU? The part of context of PCB. What is that context? The register values. Fine. But sir, before this process went to CPU to run, some process was there running na? Yes. So you know what happens? You know what happens? It's an exchange offer. Whatever process was running, its register values were there in CPU. Those values come out. Those values will come out, and those values I will store in that process's PCB. Let's say P2 was running before. P2 leaves CPU. So it's all register values I will have to store in the PCB of P2. I means operating system. And this process P1 wants to enter into CPU to run into CPU. Then P1's all register values from its PCB taken and stored into CPU's register so that P1 can run. It is something like, let's say me and my friends are playing from a same computer system a video game, but we want to play our own games, own games. But the thing is, the video game is shared and we don't want to wait for long. So we decided one thing. Let's do one thing. I will play 15 minutes, you play 15 minutes. I will play my game of FIFA 15 minutes. Let's say in those 15 minutes, my game was not completed. Let's say I'm playing some kind of a tournament and it is not completed. I will do one thing. I will save my progress. The gamers are always into the picture in this example, can easily understand. If I'm playing, my tournament is not over, whatever my tournament progress is, I will save it at some place and I will leave my video game. My friend or my sibling will come, my brother sister will come, that fellow will open his or her own game, continue playing. 15 minutes over, yes, his also entire game is not over. So what he will do, he will store his own progress somewhere separately. Why? So that later on when he will get the chance, he can start or resume from wherever he left. He will not again restart, na? Understood, right? So I will do the same thing. That fellow also doing the same thing. Whenever stopped in between, I will have to store current progress. Yes. So if I am stopping P2 process from CPU, P2 process will leave the CPU, P1 will process or P1 will run in CPU. So whatever P2's progress is there, register values, I will take out and I will store them into its PCB. And then P1 will run inside CPU. How? P1 ka every single value is loaded into CPU so that whatever progress was there of P1, P1 will resume from there onwards. ओके सर, मैं सीओए स्किप कर रहा हूँ, मुझे ओएस समझ में आ जाएगा. बेसिक्स ऑफ सीओए कवर कर लो, ओएस ज्यादा अच्छे से समझ में आएगा एटलीस्ट. So there is a particular term here called as context switch. The basic meaning of context switch is what? A process, running process leaves the CPU, other process goes into CPU. P2 was running in CPU, I am taking P2 out and P1 is now running into the CPU, going for running in CPU. That is context switch of process. But it is not actual meaning. Actual meaning I have explained here. P2 process was running, its register values were there, context, called as context. So that context taken out of the CPU, stored it in the PCB of P2. Now P1 will go and run in CPU. How? The context of P1 loaded into CPU. So in general, when we talk about context switch, we'll talk about one process leaving the CPU, other process going into CPU, switching between process, context switch. But actual meaning I have explained here. So context switch will have two things. One is context save of running process from CPU to PCB. That process PCB, it's PCB. And second thing is context load. Two steps are there. Loading the context. Loading means loading in CPU of next process from its PCB to CPU. From its PCB to CPU. That is the actual term. Now, my dear friends, I will tell you the basic definition. Basic definition of context switch is switching between from one process to run another process. CPU will switch one process to another process means one process will leave the CPU, other process will start running inside the CPU. Fine. That is the context switch. You must understand this. We will have that requirement a lot in the process scheduling algorithms. M is having a really great question. Sir, is process scheduling algorithm itself is a process? No, not always. Process scheduling policy sometimes implemented with the hardware also. Like in round robin, people who don't know about it, it's okay. But I want to answer this. You know, in round robin, what happens? There is a timer. That particular timer is set by hardware. As soon as that particular timer is over, the process is context switched. Process is taken out. It is preempted. How? Interrupt is sent to CPU and process is taken out. Kernel means operating system comes into the CPU and then schedules it. Sometimes operating system is having that CPU scheduling algorithm. So what happens in that case? Sorry. Meanwhile, after after every few milliseconds or nanosecond or something, after at a particular event, operating system runs in between the processes. In operating system running, scheduling algorithm runs, and then it schedules the next process to run. Operating system is the god, king. No one will preempt the operating system. No one will take out operating system of CPU. No, only operating system can take the other process from CPU so that next process it can run, some other process it can run, but nobody can take out of operating system from the CPU. Okay, remember that point. Next is process state. Now see, we'll have to understand that whatever process is doing at a time, based on that we define its state. Something like your state. I am into third year of BTech or fourth year of BTech, you can say like that, right? What you are doing right now, preparing for GATE. What is your career state? I'm preparing for GRE or GATE exam or GATE exam or placements. I'm in my final year, passed out. These are your state. What you're doing right now is your state. What process does at a time is process state. Okay. Now we'll have to understand there are mainly 1, 2, 3, 4, 5 states. What process does at what time? Based on that, it is decided currently process is in which state. See, when you install the applications in your computer system, let's say my phone, right now in my phone there is no any application is open, nothing, no any app is open. So what happens in that case? Currently, as far as I understand, whatever apps I have installed, those are not running. If apps are not running, my programs are not running, they are not in main memory, yes, all such kind of processes are in the new state. So I have processes, but those are not on main memory, not in running. All those processes are in new state. There, at certain point of time, we will run them, but we are not running them right now. So those all are called as in the new state. So their state is called as new state. Fine. So all those processes, installed processes, known to be new state. Now, if let's say I want to open one particular app, let's say I have opened PW app, what happens in that case? What happens in that case? If I have touched a button PW app, on that PW app opens, na? Opens, na? What happens in that case? What happens? That particular process is admitted. That process is admitted, and first of all, process comes into main memory. Directly it doesn't go to CPU to run. Now, process comes to main memory here. Among these processes, OS will decide which one will go to run into the CPU. There are a lot of processes are there. So what happens? At first place, when process admitted, it comes to ready state. Now what are ready states, sir? Ready state is that state all processes which are waiting to run on CPU are known to be in ready state. Something like batter is ready to go and bat. So that is called as ready state for that batter. Batsman is not, or batter is not inside the ground to batting. I'm talking about cricket. So batter is ready. Whenever I'll get the chance, my captain will say, I'll go and play. All those batters are in the ready state. So there are so many processes in main memory. Whichever process is just waiting for its chance, whenever operating system will say, you go to run, I will run. All those processes which are waiting for CPU called in the ready state. Next, running state. Whichever process is running in the CPU called as in the running state. So if process is running in the CPU, its state is called as running state. So look at this. When from ready state, multiple processes are there. Among them, operating system will choose process P3, you go to run. Process P3 scheduled to run. Its state changes to running state. Now from running state, there are three outgoing edges. If let's say process is running and completed, done, finish. If it is completed, it will take transition exit, terminated and done, finish. If let's say process wants to use any IO operation, then process will take this transition, waiting state. Process will come here, waiting for IO or event. So if any IO or any event process is waiting for, then that process will be in the waiting state. It is called as blocked state also, waiting or blocked state. So that blocked state or waiting state is that state where process is waiting for IO operation or doing IO operation. When its IO operation is done, process will go to ready state again, so that whenever OS will say, that process can run again. Now let's say the running process does not want to go for IO operation, not needed at all. Process is not completed, but let's say that process has forcefully preempted, taken out. I have explained that in preemptive type of multi-programming OS, it is possible. A process can be taken out of CPU forcefully. So if process is running and it is taken out of the CPU forcefully, of course it is not completed, so that it will not go to terminated state. It doesn't want to go to IO, so it will not go to waiting state. Then where it will go, sir? It will go to ready state again. So when a process is preempted, because of preemption, process will go into ready state. Fine, understood that? So these are 5 stages or states where a process can be based on what exactly current process is doing. If process is using IO operation, it is in blocked state. Running in CPU, waiting for IO, waiting for CPU in the ready state. Completed, terminated, not yet arrived, new state. Fine. Completed process has its state terminated. All processes which are in waiting state, IO or event. Now look at this. Whenever you say a process comes from new to ready state, process comes into main memory. Before that, it was not in main memory RAM. It was stored in your disk, secondary memory, somewhere. Whenever you install your app, it is there in your internal storage, right? Same thing. It is not in main memory RAM. It comes in RAM here. When it is running, still in RAM. Blocked state, still in RAM. Terminated, out of the RAM. So if I would like to tell you, in these 3 states, when a process is, the process will be there in RAM. When not admitted at all, process is not in RAM. When process is terminated, it is removed from RAM, so that process is done. So its entire part, whatever part is there, removed from RAM, so that it can be used for other process. Okay, now transitions. New to ready, when a process is admitted, when OS is bringing a process to run, transition. Ready to running, when a process is dispatched to CPU. When operating system decides P3 you run, so that P3 will go to CPU after context switch. Running to ready to running. Running to terminated, when a process is completed, takes transition running to terminated. When a process is going for IO or event, takes transition running to blocked. Running to ready, when a process is preempted, forcefully taken out of CPU, preempted. When a process completes IO or event, then it will go from blocked to ready. Look at this, from here to here, not allowed directly. If any process completed its IO, it will not take the CPU directly. No, it will again go to ready state. When OS will say you run, then only it will go to the running state. Okay. Now, two transitions are such transitions among all. Transition means from one state to another state. Only two such transitions are there which process can initiate by itself. Means process can initiate and those transitions will be taken by its own wish. Yes. And those are one this and this one. That's it. Rest all will be done by operating system. Without permission of operating system, process cannot take other transitions. That's why these two transitions, running to terminated, process is done, its own choice, my work is done, I am completing, process will tell operating system, terminated, done. But process can initiate. If process wants to IO go for IO operation, this transition also initiated by process itself. So these are the two transitions which are voluntary. Means process can initiate by its own. Initiated by process itself. Remaining all transitions are done by OS, initiated by OS. One particular thing I should write here. There is a particular thing called as dispatcher. I'm sorry. Dispatcher is that particular thing which performs context switch. Taking a process inside the CPU, taken out of the CPU, context switch is performed by dispatcher. Okay, that is why you can see here why I have written here as a dispatch. Dispatch, why? Just because process taken to ready to running state, who will do? Dispatcher will do that. That's why process will be dispatched from running to ready by dispatcher. That's why that word is there, dispatch. Fine. Okay. Now, non-preemptive system. Non-preemptive system is exactly same. Only thing is this transition is removed. Why? If a process is in the running state in the CPU, that process cannot be taken out of the CPU without its wish. Cannot be forcefully taken out means process can take by its own wish terminated transition, IO transition. Termination fine, IO fine, but preemption not possible. That's why if at all you compare preemptive versus non-preemptive, running to ready transition is not there. Here was there. That was the process state for preemptive system. Preemptive, okay? Preemptive system. And this is for non-preemptive system. Okay, so for the day we are done. We have studied what is a process, then process state transition diagram, the transitions, the states. Before that we have discussed how a process is stored in main memory and lot of small detail, context switch and all we have learnt. Tomorrow we are going to discuss the CPU scheduling. Before that we will try to understand three types of scheduler, and then we will go ahead with the first type of algorithm, CPU scheduling algorithm, called as first come first serve, FCFS algorithm. So in CPU scheduling algorithms, we'll be having lot of numericals, lot of questions. and those questions are having initial part different, remaining parts are same to same, you will definitely enjoy it. And you'll need a lot of practice in that, just because questions will take a lot of time if you don't practice them. Okay, so we'll try to learn all those techniques, how we can solve the questions quickly. Tomorrow we have a session, of course, at 12, and see you tomorrow at that. Okay, thank you everyone, bye bye.